Hello, everyone. Welcome to another episode of the Day Zero podcast. We have some interesting topic mix today. We have some topics around kernel exploitation as well as some web bugs. But before that, we have a bit of stuff to say on our own end and some housekeeping.
Yeah, and kind of on the housekeeping front there, or I guess not even really housekeeping. This is a little bit unrelated, but following up with a little bit of the Minecraft stuff I've been doing, I did learn kind of an interesting use case, I guess, with regards to CodeQL, uh, that I want to
Okay.
at least shout out. When it comes to dealing with the black box, something that I've lamented a bit on the podcast before is, you can use CodeQL with code that you've built, and that is by terms of service. So what I'm about to say is technically violating the terms of like using CodeQL. But I'm not super surprised by this, but I haven't really tried before. But you can build a CodeQL database from a compiled jar. So Java class files, it's using the Java bytecode for the JVM. So generally, it is pretty high level. It is easy to decompile, although you don't actually need to be able to do the full build with what you decompile. And a lot of the decompilers aren't, or at least what I tried. I tried a couple of decompilers because my initial thought of tackling this was to just try and decompile all of the class files in Minecraft and then try and compile it all and hope I'd be able to get that working with just a few fix ups. That was not the case. That did not really work. But because you can compile basically class by class, and then CodeQL works by intercepting those compiles, as long as you can get each file to more or less build, it's able to do its analysis reasonably well, just using like IntelliJ's community Java decompiler. So what I ended up finding was this extractor dash Java. It's a few years old, but I was able to use it with like a much more recent CodeQL. Uh, it's really simple. Like it's got this class to java.py. I actually kind of did this on my own where it used the JetBrains decompiler or IntelliJ's decompiler just on all of the files. And then once you've got that, the run is where it's magic in a sense happened again. It's not super complicated. Just basically runs through, creates a big list of all the class files that I found, puts them all in a file, and then passes that over to CodeQL saying, yeah, here are like all of the compile instructions. It intercepted all the class files, and then it'll go and do its analysis and build a database that you can actually run CodeQL queries on despite being black box in a sense.
That's pretty
So yeah,
cool.
I mean, I'm not surprised because like Java is a nice language to decompile. I also ended up coming across the fact that there was a Black Hat 2023 presentation about CodeQL on black box binaries. Unfortunately, while the presentation and slides still exist, the code itself has been taken down, and it was specifically about actually creating an assembly extractor and being able to run queries on actual assembly. I didn't get to play
Oh,
around
that's a
with it
shame.
because
That
it's
sounds
been
cool.
taken down. Yeah, that could be cool. It seemed like it was a bit limited because it didn't have the same insights about like the languages like C what like for all the taint tracing and all of that. But I came across that, and I'm not sure how I ended up missing that came out during a Black Hat. But yeah,
Black Hat, it's
unfortunately,
kind of tough to keep up sometimes because they run multiple events throughout the year. They have Black Hat USA, Black Hat Asia. I think there's another one that sometimes runs that I forget, and it's not always
Europe
like
maybe.
consistent. Yeah, Black Hat Europe. And it's not always consistent either. Like sometimes some of them don't run or they run at different times. So it's and because of like the corporate and paid nature of the event, if you're not like in that loop, it can be easy to miss stuff, I find.
Yeah, I've just pulled up the presentation or the slides I was able to find. It was actually Black Hat USA 2023.
Okay.
CodeQL, also a powerful binary analysis engine. But yeah, unfortunately, the GitHub associated with this is dead. But and I am guessing because this is pretty much against what CodeQL and Semo wants to be and wants it to be used for. They don't want this to be used on closed source projects. Like that's a pretty explicit thing. So even what I talked about with Java is against the terms of use when it comes to CodeQL. So keep that in mind, I guess.
It is neat though. I hadn't really thought of the ways it could be used on those types of languages where it's compiled to bytecode instead of machine code. Um, technically, I guess you could do something like this with C if you take a decompiler and try to work its output into something that's buildable, but that's a lot more difficult to do compared to bytecode where you have that higher level intermediate format.
Ninja can give you Python, can't it? So like, can't I just like build it into Python and then and they give that?
There you
I
go.
am joking by that one. That would probably not give you a very good,
Probably not.
very useful result. But yeah, I mean, some of the decompilers actually could be pretty decent for that. But as you get to larger and larger projects, I feel like, because even with decompilers, I don't know, other people have talked about doing something like that where they'll decompile and then be able to recompile the system. I've never had success with that, apart from like a CTF, like a really small binary. On anything large, I've never had something that could actually be recompiled wholesale like that.
Yeah, there's so many nuances that you can't really account for generically, at least.
Yeah.
Yeah.
But, you know, I know with JavaScript, it's been a thing to run it on the web a little bit with JavaScript you can pull down. That's kind of open source, kind of more gray area. Yeah, I don't know. I was just interested on the fact like it was relatively doable here with Java to get something decent. There are a few places where the compilation, I think it might be missing a few steps, like a couple files weren't able to be recompiled or weren't decompiled properly. I'm not sure how deep the analysis goes on that because I was able to query into them. So like worked to some degree, but there are probably some faults with it, but still rather useful for what I'm doing at this stage, which is just trying to get a feel for the code base and stuff. And one of the other things when it comes to decompilation is I was using the fabric mappings, which basically a lot of reverse engineering work has already happened on Minecraft. Like they do obfuscation, they do some of that
Understandably.
work. But there's been a lot of work on reverse engineering, so in like naming things and knowing what things are. So that helps a lot too with producing a nicer source code that wouldn't necessarily be available on all Java class files. But yeah, I thought that was kind of a interesting thing. So yeah, more wins for CodeQL if you're willing to
Yeah,
violate
I was about
terms.
to say, especially where we like to talk about CodeQL a lot, and you were talking about, some of the Minecraft stuff recently. That is really cool that you're able to leverage it like that, even if it is a bit, dodgy in a sense. Yeah, the other bit of housekeeping is we are going to be giving a training at Hardware IO USA 2025. So wanted to give a bit of a shout out to that. I think we talked about this a little bit before we left on our summer break, but yeah. So our training outline and everything is there. It's going to be targeting virtualization, mostly with a focus on KVM, but also talking a little bit about like security hypervisors, talk a little bit about like the PS5 hypervisor, as well as like the mobile hypervisor platforms with Samsung's real-time kernel protection and some of Huawei's stuff. So yeah, if you're interested in virtualization or some people who are and are, looking to take a training, especially if you work at a company or something that might be wanting to cover it, we'd appreciate if you shared some information about it. Trainings are something that Z and I have been wanting to do for a long time. So being given the opportunity to be able to do it at Hardware.io is very cool for us. And yeah, we'd appreciate anyone who would want to sign up or know someone who would sign up. And
Yeah, and I
yeah,
think
want to
we
give a shout out.
talked. I think we talked about before our winter break, not the summer breaks. I don't think
Oh,
we
sorry, that's what I meant to
we
say.
did. Yeah, I
Winter
figured
break.
as much. Actually, I commented on that and realized I was muted, so you didn't hear it. But
Ah,
yeah, like you said, the focus there is starting off with KVM just because that is a fairly accessible open source and or hypervisor that a lot of the like I mean across the hypervisors a lot of them are doing at their core very similar things. So like dealing with KVM, dealing with Hyper-V, you've got kind of some core foundational concepts that we just need to cover in a training before we get into kind of where not necessarily more focused on, but as we get to the more interesting, in my opinion, parts of like the security-based hypervisors, things trying to actually enforce security rather than just being like a VM machine sort of deal. So yeah, that's kind of like our training's leading towards that and pulling up there, starting with KVM, but definitely applies elsewhere and would be useful even if you're not necessarily looking at KVM itself. Just kind of start approaching other hypervisors too. And I mean, this is one way if you want to kind of support what we're doing, even with the podcast to help us keep going, is also through the training. Hardware IO is kind of the first place. Hopefully, we'll be able to give this elsewhere too, or some other training, like Spectre mentioned, something we've wanted to do for a while. So, yeah, giving you guys a bit of a shout out on it.
Yeah, for sure. And yeah, like what you were saying, KVM is just a great vehicle because it's pretty widely used, it's very useful, and it's one of the few open source implementations. That is kind of the thing with hypervisor that makes it a bit hard to get into, is pretty much every hypervisor that isn't KVM is closed source because it's from like mobile vendors which like to have their stuff closed source if they can help it. And Hyper-V is the other big one, which obviously it's Windows, it's Microsoft, so it's not open source. So yeah, it can be a little bit difficult to approach, and that's kind of what we're trying to address in the training.
Yeah, and then it's also maybe worth calling out the fact that VMware is moving some of their stuff onto KVM, so see a bit more adoption of KVM stuff. I think ESXi is still staying kind of in its own area.
I believe it is, yeah.
I believe it's the workstation that they're moving on to a KVM base.
Bit of a side note, but VMware is going to be fascinating to keep an eye on because of it's been a huge mess, as anyone who's used it knows. With Broadcom's acquisition of it, it's just been kind of all over the place. And it seems like maybe their move to leveraging KVM is because they're looking to kind of offload some of that development overhead. But yeah, VMware will be interesting to keep an eye on in particular.
Yeah. Yeah, I mean, I know a lot of companies are just starting to move away from VMware, period. Like, they've just lost trust because of the Broadcom stuff.
Yeah, and some of the changes they've tried to do with licensing and stuff. It's unfortunate because for years I've always raved about how good of a product VMware is. And like, I still use older versions of it myself, but yeah, it's really sad seeing what's happened with it, but sort of off topic, I guess.
Yeah.
So yeah, I mean, getting onto some topics. So we do have a few vulnerabilities and interesting exploits to cover. The first of which is posted on DoyenSec and is about bypassing file upload restrictions for client-side path traversal. So this is something I know you like to talk about, C, and I'll let you take it away.
Yeah, and actually with this one, I'm less interested on the actual the actual exploit is kind of the interesting thing here. Not so much the client-side path traversal aspect. Ultimately, because of the client-side path traversal, what they need to do was they need to have a upload that looked like a JSON file. However, they couldn't just upload a JSON file. So they need to craft, they talk through two things. First one I'll mention here is they do a WebP. So they bypass their image upload file type restriction with the WebP format. So they need a JSON that looked like a WebP file. That one was fairly easy because all it did was basically a check string and look for the WebP string, which is the magic bytes for WebP. So just look for that in the start of the file. It checks that the magic bytes are present at offset 8, and that's it. So that's kind of trivial, easy bypass. The PDF one was a little bit more interesting, and kind of one thing I wanted to call out, which basically they had the same magic byte check, which was for %PDF. However, PDF does not require that the PDF header actually be the start of the file. It can be basically anywhere within the file. I believe the library being used only looks within the first 1024 bytes, and that's I believe file actually only reads the first 1024 bytes in general also. And so just going to look for that within the start. So that's easy enough to do. With JSON, you can get it. Like, you can create a JSON blob, get a string in there, and get %PDF in there. That's not really an issue. But then they also needed this to be parsed by pdflib, which would try and parse it as a valid PDF, and it would try and load the PDF document, and as long as if any errors were thrown, it's not a valid PDF. And they needed to actually have pages, so they had to get around that a little bit. It didn't end up being too difficult. The main thing that they had to change was replacing their line feeds for send 0A with a space instead, which still allowed it to be recognized as a PDF, but would fit into like a JSON, which you can use spaces. You can't do new line. Well, you can encode new lines into like a string. So like you can have new lines in JSON between your elements. Like if you have a new field, you can do like a new line in the field there. That won't break JSON. But what you can't do is a new line inside of a string. So unfortunately, like Spectre, I know our alignment isn't great, but where you've got like the colon, start of strings, a double quote, and then actually I highlighted two strings there, where you've got a whole string there. Like you can't put a new line in there. You would have to encode it as a /n as your new line.
Mhm.
That's how you would put a new line there. If you put a new line there, that would break a lot of parsers. And so the issue with trying to do that with PHP with PDFs, as I would understand it, is you'd have a new line and then you wouldn't be able to just start like you couldn't then have this /type, for example. I'm not sure if that's exactly where new line would go. I don't. It's been a long time since I've looked at PDF format, but you couldn't like do /type next. You would have to do a double quote /type, which would then not be valid PDF. So you need kind of the whole thing of the PDF document to sit inside of a string. So that's why they need to do this with the new lines, or at least that's how I understand it to be. Basically replacing new lines with the strings or with the spaces so that they could kind of have something valid that would be parsed but not break JSON. So yeah, new lines can be used. That is a little bit tricky, but not where they would need them to be used. So yeah, I thought that was interesting. It also kind of leads into the whole thing with polyglot files. So while JSON wouldn't be included in the polyglot database, I did want to shout that out. So this idea of having a file that parses as multiple different things, in this case JSON and PDF, is kind of useful to at least be aware of. So there is this polyglot database. I was kind of disappointed to see that this hasn't been touched in 7 years. But it does contain a lot of these polyglots, like a 7-zip that's also a jar, and they've got like a BMP that's also a jar, ELF jar, ODT, and PDF. So that's a open office document type and a PDF, along with being executable as an ELF, and it's a jar, so you can give it to Java to execute. They've got a lot of these sort of random polyglots that can be useful to know that they kind of exist and it's possible to create something that's a polyglot in these ways. Some of these I can't see a good reason why you need them, but some of them, like a image file that also could be a Java archive, fair enough. And that is the thing. A lot of the archive formats are pretty permissive. Like especially zip is really permissive. The zip header can like appear anywhere, and it lets you do a lot of things. But yeah,
Which makes sense because you typically have, like, it's not too uncommon to have a zip or some archive embedded in something else. You kind of have that whole design paradigm. So
yeah. Like I think kind of the history on that goes back to just how like tar worked back in the day.
yeah.
In terms of being able to pull things out or be able to reference something that is tarred. But yeah, I see even a Swift file down here, so don't know who still works with those, but if you do, there you go. But yeah, I mean, it's cool to be aware of this sort of thing. It was fun to see kind of that. I mean, JSON wouldn't actually be on this list. It doesn't have like a JSON and a PDF as one of the examples here. They do have, so I've been talking about all these things, but they do have like JPEG and PDF as an example. So they do have some PDFs on here. JSON won't quite be the same fit, but it still feels like it's the same sort of thing going on here. So yeah, I thought it was kind of a fun exploit to see here.
Yeah, I mean, it's not too often that we get to talk about polyglots because you don't really see them outside of CTF environments very often. They're just not super practical or necessary in a lot of like real world exploits. So to see an example of where it is practical is pretty cool and a good opportunity to talk about them.
Yeah, and this does feel, much more realistic for something like JSON. Needing to pass JSON is definitely a format that you see a lot of things just requiring because it's used so much in the web now.
So continuing on web a little bit, we have a post from Asset Note on PHP and a bit of an obscure PHP footgun. So it goes into a little bit of history on like some PHP footguns, like magic quotes and whatnot. I
The
figure
good
you might be
days.
yeah, I was gonna say I figure you might be a bit more familiar with these because back when I was writing a fair amount of PHP, I wasn't really into security specifically. Since I moved into security, I've barely written any PHP since then, so I don't have that overlap. But yeah, I mean, PHP is always fun to talk about with some of the weird things that it allows. And this post goes into yet another weird thing and just kind of a difficult situation to deal with, I guess, if you're trying to account for it with PHP. So I'll let you get into it, Z.
Yeah, and I'll mention, the days of register globals on PHP apps, those were definitely some fun days. You could think of like the mass assignment style variables, except it was like everything was vulnerable. You had register globals, and like any variable you pass it is now registered and can overwrite the existing variables. Tons of fun. But yeah, that is back in like, I'm pretty sure that was disabled by default around PHP 4. So maybe it was definitely off by PHP 5. Anyway, what they've got here though, and kind of the foot gun going on, is register argc argv. The idea being, occasionally PHP, we usually think about this as being on the web, but some applications will also have a command line interface where you can execute on the web, but you can also go ahead and do like PHP space file name, and like it'll run as a nice little CLI application. It gets used for, a lot of times it's used like a configuration thing. While this isn't a PHP example, because I can't think of one off the top of my head. I mean, obviously Craft CMS does it, but one that I'm more familiar with is Ghost, where you have a JavaScript application that you can run Ghost and like configuration variables to change. And it's also the server, it's also like the main application that you can run for your blog. And so you'll see these sort of applications where they can kind of be run in a dual environment, but most of the time and most of the code's going to be written with the idea of you're accessing this on the web. And how you detect that it's being accessed from the command line environment is actually a little bit of a tricky problem. And so one of the common pieces of code that you might see is just if server argc greater than 0, or like server argv like is set server argv, because what register argc argv does is it means that what PHP will do is it will set these server argc and argv, and that is very much like in C, argc argv is your main, like it's just arg count and arg values. How many arguments are there in this array, and which is argc, and then the actual array containing those values in argv. And that will be used to pass in command line arguments usually. What register argc argv does is if it's on, it will basically take that out of the query parameter. So in just your query line, you could have argv equals whatever and actually start passing in kind of arguments that'll be parsed as part of the command line interface, or at least will be placed there. So the question is like, how do you determine if you're actually running in the CLI? And a common piece of code is to just look for if is set that argv. And the problem there is, with register argc argv being on by default, that is a default configuration option that's turned on. You can control that with query parameters and make it think you're running in the CLI, which is generally going to be more permissive. And in fact, what they were able to do here is, basically any of these arguments could basically just be passed in, like vendor path, base path, config path, whatever. All these paths could be passed in as a URL option, and then passed to the server or the server will treat it as though you were like the admin on the command line, because it thinks it's coming in from the command line, which is this query string, dash dash config path, and passing it in. And sorry, I think earlier I had said argv equals. That's incorrect. How it gets is it'll parse the query string as though it were like CLI.
Yeah, what's the deal with that, by the way? What's the use case for that? Like, that just seems like an insane thing to support. I don't know if you might know what the intention was of having that as a feature. I'm just trying to look in the docs and see if there's some kind of rationale for that. Because
my assumption would be that this kind of deals back with the CGI bin days, where, I mean, I guess PHP is still often run as a CGI binary, just, faster, like we've got newer things there. My guess would be it kind of dates back to that, where when you call it as CGI, when you use like PHP-CGI, it'll come through as a GET request, even though it's technically coming in as like a command, like it's coming in through the CGI binary, so it's being treated as a get, and I think that's how they pass things through. And like I think that's how things were passed through in some historical cases. I'm not actually sure about that. Like I'm not sure of the origin of why it exists. My guess would be that just has to do with like the CGI days. In fact, since you said you were looking up the PHP docs on that, how old is this? I guess that doesn't really give me anything about the date. Either way, one of the things of note are on applications like this, detecting when you're in the CLI can be kind of tricky. You can do this sort of just look at argv, but as we just noted, there are potential issues with that depending on your environment, but the default, that is problematic, but that is very, very common code. The other thing you can do is you can check your server request method. In the server global variable, you've got a request method that'll be like get, post, or if it's in CLI, it'll be blank. But as I just mentioned when with what Spectre brought up, when you're running it as php.cgi, that will be get. So even though that can be running in the command line environment, maybe called from a shell script or something, because some systems will actually default to the CGI binaries being like what's used in the command line too, that'll be get. So that doesn't exactly work either. It doesn't, if you're writing code to be used in like any sort of environment and not like your own environment, you can't necessarily control that, and you need to be able to detect it still. So request method also doesn't really work for that. There is the PHP-S API, which will give you the interface name, which when it's called from CLI will be set to CLI. But again, if it's coming to the CGI binary, it will be CGI, or it will be the CGI server. So like if it's light HTTPD or whatever, it'll be that. And even just CLI, kind of a funny thing. I haven't actually seen this be exploitable in the wild, but it's been something I've kind of known about for a bit. If it looks for the string CLI to be in that string rather than just looking for equality, the built-in PHP server, it has the option to kind of serve files inside of itself, is also called CLI-server, so it'll contain that CLI string. I've never seen that as an actual vulnerability, just one of those random facts I've had in my head for a while. I could imagine somebody writing code that, just checks if it contains CLI, kind of like they check if it contains CGI, which isn't a good solution. Basically, it is tricky to actually do this. There is also like the standard in constant that I think gets set on CGI, or that gets set at least when you call from the CLI, but I believe that'll also get set when you come in from the CGI binary. I'm not entirely sure about that, but yeah, like there's a lot of complexity to trying to definitively determine that you are being called from the CLI in
And
ways that can't
again,
actually be.
sort of a weird thing. Like you would think that the PHP language would provide that functionality as like some kind of macro, or very like you would think
Well,
that would be a built-in thing, especially where I could see the situation being somewhat common where you'd want to determine which environment you're running in.
I could understand that, but it's also tricky because how do you write just normal binary to do that? Because like it's, PHP is running as like the CGI bins, like it's just being called as a binary.
Yeah, that's true.
Like it's
Yeah.
just a tricky thing to do, but it is used as a privilege separation in a lot of cases. Like
Yeah,
generally
you would have to
speaking,
have
if
some
you're
kind of standard that would define like you're supposed to pass this argument to say that you're running in like the context of serving a page or something. I don't know.
yeah, like one of the things you can do is read the environment and be like, oh, there's a shell environment, so that's telling you something. But
Yeah, but
again,
that can be kind of
environments,
finicky too. Yeah.
yeah, because environments actually can sometimes end up getting filled from GIF variables depending on your setup too. So
Yeah.
there's a lot of fun little things there. It seems like it would be an easy problem, but I'm not sure it actually is. It's not something I've really needed to try a lot before. I think like the safest way to do this would be to have a file outside of your web root. That would be the one that gets executed as CGI. Um, and not like having the code joined together. Like it might call into it, but having it separate. That would probably be the most secure way of going about it. But yeah, this is just, I thought this was interesting because we haven't been able to talk about this bug at all. But this is one of those things that is used as a privilege check and is kind of easy, I think, for somebody who's just reading the code to maybe not notice that there could be an issue with this because you just look, it's like, oh, it's reading an argument. Like, obviously, I can't control that. Not really realizing that maybe they could get control effect.
Yeah. Especially like in a default configuration, like that's the big thing, because I believe they call out like the Craft CMS Docker has that set to on. I believe like there's a lot of Docker images though that have that same setting. So
Well, I believe that
that's what
it's
kind of makes
set
it
by
a
on
problem.
by default across PHP. So, like, yeah, the official Docker has it on, but also just like default install of
So
PHP.
it's kind of complicated. So by default, like the recommended default configuration and a lot of distributions will have it set to off. Though it's not for like a security reason, it's for like they say it's for performance reasons. Um so yeah, like I think by it kind of depends, I guess, on the distribution. It seems like a fair amount of things do have it set to off, but the default in non-production environments is on.
Okay, I thought it was PHP's default to have it on. Maybe I'm mistaken about that then.
Yeah, so maybe
Um,
I'll pull up a post that I'm using as a guided reference for this. So this was a pull request, or sorry, an issue that was opened on the PHP repository a little over a year ago. And it mentions that it is default to on in some environments, but they do recommend turning it off in production. So it's a bit weird there with the history.
yeah, I mean, PHP definitely does that where they do not use secure by default settings. um,
Yeah.
but anyway, kind of coming back onto this issue, they were able to, or they had some challenges with actually trying to exploit, just dealing with the fact like they didn't have a clear file upload where they'd be able to get like config path. They talk about using config path or templates path to actually try and exploit this. But the main focus that I want to have on this wasn't so much on the exploitation; it was just on that like detecting the CLI. Because I don't know, it's an easy area to overlook when you're reading code. Ultimately they
Yeah.
were able to get this with like using the templates path.
Yeah, for what it's
And
worth, I did think that was a little bit interesting, the way that they found a template escape with the twig templates and used the sort filter to execute the PHP. I thought that was a little bit cool, but yeah, it's pretty specific. And like the details are there if you want to read into that a bit more, but we don't need to go into that too much.
yeah, and they were able to use like the FTP handler to also get pulled down from a malicious server. So that's
Mhm.
just fun. I mean, PHP has those handlers, some of which are allowed, some aren't allowed. But
Bar is the one you typically see exploited, but
for RC, I mean, it's been
yeah,
less so in recent ones since a lot of things like is file no longer support bar.
yeah, yeah, it makes
They
sense.
actually, I guess they do talk about that here. Like, FAR also supports stat, but and stat in this case because it is file exists call. FAR can be used for that, but then they can't easily smuggle their FAR onto the file system. They want
Yeah, they
something
don't
that
have
can be
that
pulled
upload.
down remote. Yeah. So in this case, they were able to get with FTP, which I don't know. PHP has so many of those things, of those handlers that can result in some interesting exploits. PHP is a really fun language for exploits.
Yeah, there's a lot of like it's one of those things where it's kind of impossible to sandbox properly just because of how many different things it supports for different reasons, and just the convenience factor kind of goes against security in that way. So
Yeah, I
uh
mean, I feel like if they started PHP in like 2025, they would be able to make a lot of improvements, but because they have so much history, it's just
100%,
rough.
it's
Like,
like the legacy cruft that you have to inherit, and yeah, but a lot of that was just insecure by design.
yeah.
All right, moving away from PHP, there was a open wall advisory that was published, and it is about rsync, which you may have used if you've been involved in like trying to set up servers and like doing some file like automated backup stuff is commonplace to see rsync. But yeah, there was multiple vulnerabilities published. Pretty much all of them have to do with checksums. And there was one that you found particularly interesting, right, Z?
Yeah, I mean, it's interesting to see because rsync is a well-used system. I believe there's also like some impact here when it comes to like Google Cloud Storage and stuff. Because I know like Google Storage just supports rsync, like natively. So yeah, like having like a heap-based buffer overflow there is kind of interesting too. But yeah, the ultimately, that just comes down to like they have a max length and they have a user provided length, and they also they have like a user provided length, but they also just have a fixed sum length that gets used, so users can go out of bounds. Not that interesting in the grand scheme of things. But the second vulnerability here, and actually also just to touch on the uninteresting things, they also have like some symlink issues that we have talked about dozens of times, kind of those classic sort of races in symlinking and dealing with that. So the interesting one, or slightly interesting, was the info leak on uninitialized stack content. And the info leak here turns out to be something that it's an info leak, but it would also be rather difficult to exploit. But it's also kind of an interesting, I guess, thought experiment about exploiting and how you'd use some of these. And this description we have here is: a flaw was found in the rsync daemon, could be triggered when rsync compares file checksums. This flaw allows an attacker to manipulate the checksum length, as a lot of these vulns have been, or as a lot of these vulnerabilities are, to cause a comparison between the checksum and uninitialized memory, and leak 1 byte of uninitialized stack data at a time. And I think that's sort of, so one, it's just 1 byte of data of uninitialized stack data. So it's on the stack. You might be able to get some information off that, but this sort of uninitialized data read, where it's just a read and you're not necessarily... Actually, I guess I will say, I thought when I read this at a glance, I did notice that that was 1 byte at a time. So they are actually implying that you can get the full... You can perhaps get the full thing back. I'm not sure. I didn't go commit surf and see the code on this one. My initial thought, though, was that this was sort of, it's reading it, but you're not necessarily getting the byte itself back. You're just able to tell kind of a side effect of that read attempt.
Yeah, you're able to side channel it.
Yeah, that was kind of how I understood this. Like, you'd be able to determine what that next byte is by changing your checksum until it actually matches. And then you can kind of go with the next byte until it actually matches and kind of leak out or figure out what it's comparing the value against.
Yeah, you can enumerate the stack values that way.
Yeah, that's my understanding of how this one would work.
Yeah, and kind of like you said, it's very rare that I've seen that be practical for getting something useful. The one case that I can think of offhand is when you're dealing with crypto. So an example is like the crypto coprocessor in AMD CPUs. On Zen 2 and lower, it had a bug where you can set like an unaligned address for the key and you could bleed into the next key slot. So even though the key slots weren't readable, because you were able to use like 1 byte of the next key that was unknown, you could kind of just enumerate all the values and check the ciphertext and compare. It's kind of similar here, where you have like that checksum and you're trying to you enumerate through the values until the checksum kind of matches. That could be useful with like encryption keys, where you could try to get like all 16 bytes or whatever for like a 128-bit key. Outside of crypto, I don't know. It's kind of hard because when you have the stack like that, yes, canaries could be. Anything that's like a secret value, really. For pointers, it could maybe be useful, but it's highly dependent on the context. But yeah, like it's not very often that it is useful, I find. Like especially because with pointers on the stack. Yeah.
Like I think that's the big thing. This sort of thing, like, you could probably work it out in the right scenario. You could probably work it out into an exploit. But odds are you're going to have an issue that's easier, because this would only be an info leak. You still need another bug, and a lot of times you're able to work those other bugs into something more useful than this type of info leak.
The other thing I would say, though, is with a pointer, where it's a lot more like short-lived, it can be kind of tough to abuse these bugs, because if you can't leak the entire pointer all in one go, odds are in the next run that pointer is going to be something different. Whereas with like an encryption key, typically those don't really change the same way. So it kind of depends on the data too of like how useful it is.
Well, I mean, if you're going for like an ASLR break, though, you don't necessarily need the whole pointer. You just want the most significant bits
If it's
of the
just for an
pointer.
ASLR break, yeah.
And
Yeah,
when you're
that's true.
dealing with when you're dealing with a stack pointer, that feels like it is going to be at least a little bit more consistent because we're dealing with uninitialized stack information. So,
Well,
um,
it's not necessarily going to be a stack pointer though, right? Like it could be a heap pointer that's placed on the stack.
sorry, what I mean is a pointer that's on the stack is going like just because you're on the stack, you've got a bit more consistency on the like what's living
Oh,
on the
yeah, yeah.
stack.
Yeah,
Yeah,
like
I
what
don't
type of
mean
pointer it is. Yeah.
yeah.
Sorry.
It's easy to kind of get confused over what means what in this case. Yeah. But at the same time, this is uninitialized stack area, so like there could still be a good bit of variation in that between your runs.
Hmm.
Um, I mean,
It's very interesting with the stack because it kind of depends. Like in a lot of regular applications, even though it's uninitialized, it probably still will be pretty predictable. But it's once you enter context where you have like interrupts and all these like different things that can happen that can change very quickly. But in this context, I imagine it would be pretty consistent. So,
yeah, it could even be like
yeah.
just an object that's always the same thing. They're very much not useful.
Yeah, could go that way too, for sure.
But it's a fun kind of primitive to have, I think, like to think about.
Yeah, like you said, the other vulnerabilities here are fairly run of the mill, not too interesting to talk about. But that one in particular is kind of interesting. But yeah, just the fact that these are also in RSYNC is, like you said, notable because it is a fairly commonly used utility. You're probably using things that use it even if you don't realize it. It is a very useful utility. So, and that's, typically that's what you see on OpenWall is vulnerabilities in these types of utilities that are used quite a bit. So, I guess that's not surprising in that sense.
Yeah.
All right, so transitioning into some lower level issues, we have a Project Zero post that was published in December, and it was titled Unexpectedly Excavating an Exploit in the Qualcomm DSP Driver. So this was a in the wild exploit that they got some information about from crash dumps in the ADS RPC Qualcomm driver. That's application digital signal driver, so it's kind of for talking to the digital signal processor. What's cool about this post though is they go into some of the detail on the process they use from going from crash logs to, trying to narrow down the root cause and the exploit strategy. And it also prompted them to look at this driver and do an audit themselves where they found multiple vulnerabilities. They have like a whole section dedicated to each one. Quickly going through them, they had like a ref count leak yielding use after free. There was also a type confusion where userland pointers could be used as kernel pointers through the compatibility layer. That's kind of a funny one. Um, there was a race UAF on the global maps in the mmap create handler. This one was a little bit interesting because they had some locking to try to prevent races, but the lock was on the file, so it was local to that file descriptor. They didn't lock for accessing on the global maps, which is a little interesting. You'd think it'd be the other way around typically, but it was just kind of two different concurrency contexts that they weren't accounting for. There was a info leak in the mmap find functionality, as well as another race use after free in the internal munmap handler. Lots of bugs. The one that seemed to be used in the wild was a map collision UAF, where if you have multiple maps that can fulfill a find request, you could get a reference dropped on one of them, leak that reference count, and then cause a UAF on it. That the crash that produced kind of leaks the exploit strategy a little bit, which is where I think the post gets really interesting, because the channel ID of the map was involved in warnings that were spit out in the kernel log, and it seemed to be this high value. Possibly it was being used as like a egg or a tag for trying to, confirm an overlap for the use after free. And the crash also indicates this I notify handle event function in the call trace, which when you look at it, this function does the variable sized allocation for the event, which kind of sets off alarm bells because when you're trying to exploit a use after free, variable sized allocations are very useful primitives to have as an attacker. It kind of lets you hit like whatever bucket you want for however like large your target allocation is. So they found that interesting. And after looking into it further, they found that the modification time on the event inode field overlaps with the channel ID. Which again, like when you're attacking, you typically want to have some kind of observable side effect when you get an overlap. You want to be able to check that your overlap succeeded before you try to do anything critical and potentially cause a crash. So, it's very interesting that that modification time overlaps with the channel ID, which can both be like kind of set and obtained. So yeah, in this case, it seems the exploit overlapped the inode event with the fast RPC mmap struct, and then once that's confirmed, they can free the event inode and reclaim that mmap struct with a pipe buffer for doing info leak and read write. That's sort of a classic technique that's been pretty well documented at this point. But yeah, I mean, there's a lot of technical information in here that I skipped over because it's one of those longer P0 posts. It's hard to really cover everything. But I thought it was really cool how they went from a crash log to trying to determine the exploit strategy, because going from a crash log to, root cause the bug is fairly run of the mill. Like that is typically what you do when you get a crash log. But trying to infer information about the exploit strategy the way they were able to here was really cool and something that isn't talked about quite as much.
Yeah, well, it's not something that's necessarily needed to be done very often outside of like specifically this sort of threat hunting.
Yeah.
It is kind of a specialized area because if you're working on an exploit, you don't kind of need to figure out what your strategy was. So being in this scenario is interesting. It is also just a bit of a reminder also about OPSEC when it comes to your exploits. Well, in this case, they're working on something happening in the wild, so it is a little bit different, but it is worth remembering that these sort of crash reports can kind of end up burning your exploits before you're ready for it. So if you want to go for a bug bounty on something, these sort of crash reports can sometimes cost you a bug bounty if they get the crash report, they root cause your bug before you figure it out enough to actually report it. And that's kind of one reason why it's usually recommended when you're doing research to make sure you've got these off. Obviously, it is a different scenario than an in the wild thing like this, where I'm not suggesting that people just generally turn off crash reporting, because I think that's useful both for developers to have that information and just generally.
Yeah, I mean, I'll say I get in the habit of turning off crash reporting and telemetry on everything that I use just as a rule. Even if it's not something I'm targeting, it's just kind of, hardwired into me. But yeah, I mean, OPSEC around crashes is something that's not really talked about a lot. And it kind of makes sense that it's not, right? Because when you have like these organizations like Threat Analysis Group that rely on them, they don't really want all their techniques that they use to try to figure out things known necessarily. Kind of benefits the attacker to do that. And equally on the attacker side, you're trying to make it so that those crashes don't happen in the first place, ideally. And if they do, like, you want to try to obfuscate what you're doing a little bit. I wish I remember where I saw this recently, but I vaguely remember something where I think it was on iOS, where the attackers would intentionally cause a crash that was just a denial of service. Like, it wasn't useful at all. But because they knew that there was a potential for them to have crashes in their actual exploit chain, they would basically flood the crash logs to make it, to basically pollute it with garbage that wasn't interesting, to kind of hide their crashes that were more interesting. So you kind of have that adversarial relationship there too. And it's funny with these crash logs because how useful they are and how like quickly they get your stuff burned really depends on who's doing the analysis. Because I'm reminded of in the PS4 days, QWERTY had the BPF exploit in the PS4 kernel. It was actually a FreeBSD kernel exploit that impacted FreeBSD as a whole. But a crash report had made its way back to Sony, presumably, and they had killed the trigger for the exploit. So it was a race UAF, but it was using like the way the write primitive was obtained was what could cause a crash. And when they got their hands on it, they were like, okay, this looks dangerous. I see there's like memory corruption happening here. They just removed that write handler. So the bug was still there. They just removed like the way to to trigger the write, which in that case was sort of effective in a sense. It's easy to just kind of call it at the surface level and just try to address the crash and move on. Whereas with threat analysis group here in Project Zero, like they're really digging deep on like not only what is the actual issue, but like what exploit primitives are they using. And P0 is actively trying to go after killing exploit strategies too. That's kind of what they have going on with their KCTF and why they're paying out for exploits even on known vulnerabilities if it's a novel technique. So it's just really cool seeing the dichotomy of the different approaches and how deep people are willing to go on inspecting these crashes. And like I said, it's not something you tend to get insight into too much. So this post is excellent. And it's been shared around a lot. So I'm sure some people listening have already seen it, but fascinating post. Definitely worth reading into a little bit more of the technical details beyond what I've covered here.
Yeah, definitely an interesting post. And like I said, interesting insight on that side of operations. Like it's not something that we get to see a lot. I mean, every so often we get like a presentation, like a Black Hat DEFCON presentation about or something like that. We get the odd post. Actually, Tag's been I don't know. I mean, part of me wants to say like over the last few years, Tag has kind of been putting some information out there, which is nice to see. But they're also not like a super active publisher of any sort of information either. So yeah, kind of mixed on that.
Yeah.
But yeah, interesting still.
One last thing to note that they talk about a bit in their conclusion is one of the vulnerabilities here. Actually, sorry, two of them were not fixed by Qualcomm in the standard 90 days closure deadline. And one of them is still a 0 day. 145 days after it's been reported. So I think we might have had this discussion before, and I don't think we want to go into this rabbit hole right now. But with some of these vendor drivers and Android in particular, Qualcomm is guilty of it, but also I believe like Xenos has had similar issues where they've had stuff reported and things just kind of get lost in the mix, or the impact, they don't agree on like the impact or exploitability of a bug, and they're just kind of left to sit for a while. They're not really taken too seriously sometimes, and it seems like that has kind of happened here. That one of these bugs is still exploitable on modern Android devices, or at least modern Qualcomm Android devices. So
yeah, it's hard to read into exactly why bug doesn't get fixed. Like, is it that they're being late, or is it that it dropped out?
Well,
like somebody just forgot about it. Sorry, go ahead.
I've been thinking, like, I remember some particularly on the P0 bug tracker, there have been some of these reports before with Qualcomm or similar vendors, and we've gotten a little bit of insight into the back and forth where like P0 has said straight up that the vendor doesn't agree that this is an issue or something. Like we have seen that before.
Happened, but I mean that it's happened, but it's hard to say on any specific case, I guess, that
yeah,
like,
for
what
sure,
the
I agree.
reasoning is, because there are kind of more benign reasons that like, oh, the person assigned to this left their job and like it got lost because of that. Like it could have like, I mean, that isn't a great thing like for a company to have that sort of thing happen in general, but like there are kind of more benign reasons why bugs kind of get lost or overlooked.
On a whole, though, it seems a fair assessment that like Qualcomm and these drivers don't take security super seriously. I mean, I think that's hinted at just at the fact that they audited this driver for a couple weeks and were able to find like 7 or 8 different bugs. Like,
Yeah.
At this point in 2024 2025 on Android, especially because this driver can be reached, they mentioned like this driver can be reached from pretty unprivileged contexts. It's not directly accessible to untrusted app, but it can be accessed from like the DSP service, which you can pretty easily traverse through user space to get that level of access. So like these drivers, like because they're in the attack surface, you would kind of expect them to be a lot more well vetted and reports be taken more seriously on them, and they're just not. And that's kind of an unfortunate reality, I guess, of the vendor side in the Android space, because Android's so interesting where Google puts in so much effort to try to reduce attack surface. They have like SE Linux. They harden the kernel core quite a bit. They work with Linux a lot to try to get core vulnerabilities patched. They work on exploit mitigations, all this stuff. And then the vendors come in and they're just like, screw it. Whatever. Like it's like completely going against all the efforts that Google tries so hard to secure the Android ecosystem. And they kind of call that out in this post, that like the vendor drivers and stuff like this are kind of the weak link.
And I definitely agree on that front. Like when I was kind of challenging the motivation behind just Exploit getting dropped, I'm definitely not questioning really the fact that these sort of things are often are definitely where the weak links has been moving when it comes to Android. These sort of bugs that exist in the slightly privileged off areas, so where you've got like the device driver not directly accessible from any user app, but they would have to go through a service and then compromise the service. Then you're able to start hitting it and find these sort of bugs, which because they're slightly privileged off, they haven't been as well examined over the years, where hardening has happened in more core things. Now the bugs are being pushed off towards these areas which are slightly more isolated, slightly like, an impact here isn't going to impact every phone or every Android for a particular version. It's going to impact that driver. But that is where I feel like a lot of bugs have been moving. We've actually talked about that a few times on the podcast, how, the exploits are kind of moving a little bit away from the core because Google has been taking all of these steps and the vendors are still kind of screwing things up.
Yeah, and I mean that is a fair point too, is that in a sense Google's efforts aren't entirely ruined, because where you're having to focus on the vendor drivers, you don't really have like generic ODay chains that are hitting Android like you did say 10 years ago. So like, the things that impact specific vendors and specific devices are a lot easier to find, and they don't have as much value. But still, like, that is an obvious weakness. So Android's very interesting in that respect. It contrasts heavily with iOS, where because iOS is a walled garden, it's locked off. Apple controls like all the code that's running on the device except for the apps. They're able to build a lot more of a resilient architecture and security, where they have, for the most part, uniform security across all their subsystems. I mean, obviously some subsystems are weaker than others, and there are like bug farms in a sense that are targeted by attackers, but it's not the same as Android, where you have such a stark difference between the core code and the vendor drivers. It sort of has the same problem Windows does in that respect, where Windows, the operating system, is fairly secure, and then you have these gamer where RGB drivers that give arbitrary read write primitives as an ioctl handler. It's not quite that bad in Android, but it's more towards that than it is iOS, which, typically you would compare iOS to Android, but in a way, Android is more similar to Windows in that respect.
So I definitely think we need to make a clip of you just saying Windows is fairly secure and just leave it at that.
The Windows core is.
I know what you're saying, and
there's
I do
nuances
agree.
there too, though.
Windows has been one of those places where they have a very poor reputation, but in practice, I feel like a lot of that is just because of the third-party vendors and like a lot of crap going on there. I don't think it's actually Windows itself. Windows has its issues. Most of that comes down to cruft and age, like things that they maintain.
Like Win32k.
Yeah. And not like anything new out of Windows has generally been fairly solid, as I understand it. I mean,
yeah, and they've done some efforts, like even the legacy code like Win32k, where you still have the meme bugs. For the most part, Microsoft's done a good job of making that code hard to actually reach from an untrusted attack surface. Yeah, I mean, the situation, like I'm trying not to go too much into Windows here, because I just kind of brought that up as a sort of point of comparison. Yeah, no worries. But like, I feel like it is kind of a good comparison, because you have that thing where vendors are able to get highly privileged code into the code base, and it just kind of taints it and leaves these gaping holes.
Yeah. And that is, a key problem. And Google has been taking steps towards even trying to resolve that with like the common kernel.
The GKI.
Yeah. Like they actively recognize this is an issue and they're trying to solve that, or at least trying to mitigate it. But yeah, I mean, we see it here. The drivers, the third party things still tend to be, or are very much the issue, and are where I think a lot of exploits are moving towards.
Yeah. Kind of going against that philosophy, I guess, though, we do have another Linux kernel bug in the episode that was reported to KCTF. And this is a vulnerability in the virtual sockets virt.io subsystem. And it's kind of funny because at first blush, this seems like a fairly simple vulnerability. And in a sense, like the code smell here is very obvious. So they have a snippet of virt.io transport destruct. And for those who are just listening, they basically just grab the virtual socket object from like the parameter that's passed in and they free it. And then that's all the function does. It doesn't immediately change that field or anything. Like it doesn't immediately clear the reference. And that's kind of the core issue here is that even though this reference can be changed later, there's a race window where that pointer could be left dangling and something else could end up using it. The control flow for how that happens is a little bit complicated because it involves like deferred or delayed work, which is kind of its own beast inside of the Linux kernel, where you can have routines that run at some later point. They're kind of scheduled to happen later. So yeah, like this destruct function would free the sock object. It wouldn't take ownership when doing that. What you could do here in terms of a high level overview is through a connect call where you change the channel ID, you could get that, virtual socket freed. And the worker thread, after doing some other tricks, when processing a reset command, will write to that dangling virtual socket. There's a lot of information on the whole flow there and the exploit strategy that I won't go fully into. Something interesting here, though, and sort of unique, is that the path that they have to trigger to get that right will inevitably trigger a null dereference later on. Which is obviously not useful to you as an attacker. You don't want to be triggering crashes like that. But
yeah, it is actually important to note here that the KCTF environment has a panic on oops, which will panic then on null deref.
Yeah, so it's not just a warning that you can kind of hope to get by with.
That's
I think good that you brought that up.
I think that became the default after the Project Zero post about exploiting a null deref, where they exploit the null deref handling, not the actual null deref, but in all the handling of it.
Yeah. But because that null deref would happen in delayed work, as it's basically handled in the timeout handler where that would happen, that timeout is 8 seconds, which is more than enough time for the exploit to run and kind of fix things up before crashing.
Is that accurate? I thought the null pointer deref actually was happening pretty quickly. Immediately after triggering the UAF step and executing the race condition, an unexpected null pointer dereference happens in the following call stack. Because my understanding was that this generally happened pretty quickly, and then their solution to that was basically grabbing a lock, so then that wouldn't grabbing a lock and interrupting that lock. And so because that lock was grabbed, this thing then could have run, it would put into deferred, which would then delay it by 8 seconds. So like the successful route.
You're right. That's what it is. Sorry. The default flow would immediately hit it. They had to do some work to actually get that deferred work going so that they could postpone the UAF, or sorry, the null deref. So yeah, fair point. Sorry. So yeah, but with 8 seconds, like that's an eternity in the context of an exploit. And they also talk a little bit about how they use timer FD and work queues to extend the race window. This is, again, it's kind of a documented technique, but it basically makes it so it fires an interrupt on the timer expire, and then it has to go through like this huge work queue that will hold a lock for a long period of time. And they can extend the race window from a matter of nanoseconds to like 40,000 microseconds. It's quite a jump. But yeah, like there's a few like interesting techniques that are used here to make a not ideal exploit scenario a lot more ideal, which is really the art of exploit crafting in a sense. That's what you do to make a great exploit. So always like to shout out work that points that out and talks about that. And KCTF is a great source for those kinds of exploits, because they incentivize and reward writing good exploits beyond just a proof of concept that crashes on a vulnerability. So
Yeah,
yeah,
and
there's a lot
this
of cool stuff here. They also talk about like cross cache attacking, which I'm not going to go into here. It's pretty specific to Linux, but yeah, a lot of information here. Sorry, go ahead, Z.
yeah, well, on the exploit crafting side, I thought it was interesting there when you took a look at the Twitter for the author here, one of them, and he mentions that this was the first vulnerability, or sorry, this is a variant of Alex Popov's 4 bytes of power bug, which we covered quite a long time ago. But it was the first vulnerability they analyzed after joining Theory 2 years ago. Back then, I knew this VVS still ended up, that's the pointer that got freed but not nulled, ended up as a dangling pointer even after the vuln was patched, but only recently succeeded in triggering a use after free. And so this is a bug that would have taken, 2 years for them to kind of figure, and I doubt this is like active work for like full-time work for 2 years, but it was kind of one of those things where they're aware of this bug 2 years ago, and then in order to come up with the whole chain here, it took them a couple years to actually get there with it. And that's just kind of speaking to the complexity that goes into some of these bugs, because I think a lot of times, it's easy to think that these exploits just happen, people just know exactly what to do, like, oh, I did this, this, and this. And here they're kind of talking about as being like, this took, I recognized that the bug was there, but didn't see the exploit path for a while and had to kind of think about it longer. At least that's how I'm understanding this post and what they're saying there. Maybe they got it in a week and it just took them 2 years to get that week of time to focus on or something. I don't know, but it is a fairly complicated exploit flow. It is one of those things where the race flow here, that's a bug, this exists, like the free exists, the dangling pointer exists. Just how do you get all the conditions just right, and then exploit crafting? And yeah, they kind of end up with this nice final solution, taking advantage of the threading, the locks, the even a fairly recent cross cache attack. They use subslick, which I think is just Usenet security from August of 2024, so just August last year is when this paper officially was published. Kind of things falling together for that's yeah, it's a cool exploit, I think.
Yeah, and it's a good example of that case where you have a vulnerability and you just kind of sit on it for a while, struggling to exploit it or like waiting to see if there might be another path to do it. Like that is a somewhat common case in hardened targets. So it is a good way to shout that out because like you said in write-ups, it's easy to think like, you get a bug and you spend a couple days or a couple weeks and you have an exploit out of it. Like that is the ideal case, but it's not what happens all the time. So yeah, it's a good example of that. And especially in like some things like the Linux kernel, it seems like you can kind of afford to wait a little bit and try things because some bugs can end up living a very long time depending on the subsystem that they're in. So
Yeah, it's actually kind of interesting how long this one lasted, just because of the fact that this was, the
like a
initial
variant.
bug, yeah,
Yeah.
was patched, recognized like, hey, this still happens. Like the core smell, we talk about the code smells a lot, is the fact that it's doing this free without an equivalent or without an associated null right, or without nulling it. Like the code smell is still there. So yeah, like the fact that it still lived is actually kind of interesting on its own. Although there could also just be the assumption that whoever did the patch looked into it already or whatever, and therefore was like, oh no, every path will always null it, so like we don't need to do it here, whatever, like having some reasoning. But that's kind of a slightly interesting aspect too. But yeah, I mean, I at least wanted to shout that out. Took a bit of time, and this presumably will get added to the kctf repository here in some time. Right now, it's still just the PR.
Yeah, and presumably will eventually be added to the KCTF cookbook, although I haven't checked on that in a while. Is that still maintained?
I'd assume so.
I feel like I went to look at it recently and I hadn't seen stuff added for a while, but I might be misremembering. But for anyone who's not aware of that, that is also another great resource for looking at where things can be collected is Google actually has a doc called the Kernel Exploit Recipes Notebook, where they have yeah, so I just found it actually. I'm gonna bring it up, but there hasn't been anything added for a bit. 2022 was latest stuff, so maybe it's just not super well maintained anymore. But for some older stuff, this has a great collection of like links to exploits and pocs, as well as a brief summary of the techniques that are used to perform the exploit. They have
Yeah,
kind of the ingredients and directions listing theme going on there.
yeah, the directions. So it's kind of the interesting thing with this because they try to make it somewhat generic in terms of like how they're writing this, where they're genericizing what they're doing into just these clear, well, directions and stuff.
Yeah, making it
Um,
like a template. Yeah,
yeah, which is it's hard to do with exploits. So
100%. All right, so that is the main like vulnerabilities and exploits we had for the week. We do have a shout out in the form of GLibc Heap exploit training from Security Innovation. I'll let you talk about this briefly, Z, and then we'll wrap it up.
yeah, I mean, I haven't had a chance to actually go through very much of it here, but this is from Maxwell Dillon. We've covered his blog a number of times, including posts about different glibc attacks. Actually, just different. We've covered his blog in general. It's not only been his stuff on heap exploits, but yeah, I guess he did this training. I know it's offered at DEF CON, possibly elsewhere. Yeah, mentions taught at DEF CON, CanSec West, many other conferences. So had the training, was running that. Now resources for it are available freely online.
Which is very cool. I can't really recall any other cases where that's happened, where like
Someone's
training
put
material was put up like afterwards. Maybe it has happened and it's just not been on my radar, but nonetheless, it's it's worth shouting out and praise.
Yeah. I mean, like I said, I haven't had a chance to look over it. I'm kind of just recommending it here on reputation. Um,
Yeah,
I am
which
sure
is
it's
fair. Like
solid.
with Max Solon and Security Innovation, like both solid, like people and groups. So I think that's totally fair.
Yeah.
But yeah, that's all the topics we have for this week. So as always, thanks goes out to everyone who tuned in. Once again, I will just mention that we Z and I will be giving a training at the end of May at Hardware.io USA. So we'd appreciate it if you shared that around, and if you know anyone who would be interested in taking that training, give them a link to it. And yeah, with that said, we will see you next week.